And I'm sure that he's going to be very interesting, so give him the attention that you'll always give me.
Right. So I moved to Israel 3 years ago. I've been working in the space program for like 30 years. I worked at NASA headquarters for about 8 years. I ran future astronomy projects. What do we do after the Hubble Space Telescope? And then I went to work for Boeing, and I led their new science business. My job was to design and build missions that would go to the asteroids, comets, other moons, other planets. And success was if a Boeing sticker is on the rocket as it takes off. So and then I moved to Israel a couple of years ago. So I'm going to talk today about, this actually connects with a lot of science fiction, because a lot of science fiction, space related, has to do with the search for life. Alien life, intelligent life, on maybe not so intelligent life elsewhere. So this is focused on, this is all fact, the search for life in our solar system. So what I'll talk about is, what do we know about life on Earth? Because over the last 20, 30 years, what we think about life on Earth has changed enormously. And so depending on what we think about life on Earth, what kind of life there is, what conditions there have to be, will tell us where to look away from the Earth to find life. Okay? Then I'm going to talk about Mars. There's been a lot of activity on Mars. And then I'm going to talk about this moon of Jupiter called Europa. Has anyone heard of Europa before? Okay. Where have you heard about Europa from?
I was learning in Poland. I was learning about the different moons.
Right.
And I just heard that was one of the 3 moons.
Right. Europa is a really pretty amazing place, and in fact, Arthur C. Clarke, who's a very famous science fiction writer, has written a series of books: 2001: A Space Odyssey, 2010, his whole series, and the last scene in the early 1960s, the warning from the other alien civilization was stay away from Europa. And it turns out, as I'll get to later, Europa is a place it seems highly likely we'll find life. It's a moon orbiting Jupiter. 2 moons of Saturn, Titan, and this moon called Enceladus. And then what's next? So, our solar system, and I apologize, I have a very good friend who's leading the mission going to Pluto. I don't list here as Pluto as a planet. I personally believe Pluto is a planet. It's very controversial among astronomers whether Pluto is a planet or not. But so this is our solar system, just to acquaint you. So Venus, Earth, and Mars are in this area we call the habitable zone. The habitable zone is a zone where the sun, given how big our sun is and how hot it is an area where water can exist in liquid form. And why is that key? I'll explain in a second. Jupiter, Saturn, those are the outer planets. They tend to be gaseous. There's not really a solid rock with maybe oceans. It's like gas. It's condensed. They're much, much larger, much, much colder, further away. Let's say cold. I mean, if you're orbiting Jupiter, it's like minus 240 C. It's very, very cold. So it's kind of pretty amazing. How can there be life out there? But we'll see if that's possible. So life on Earth. So we know it exists. So there's a picture of my dog and my parrot. So we see life in all different forms: birds, animals, us. But on Earth, we've been finding life in really weird and unexpected places. In the lower right is a picture of some areas in Yellowstone National Park. And this is a pool of like sulfurous water. This is at about a temperature of about 95 degrees C. And all that reddish, orangish stuff that you're seeing is bacteria. So what is it? And also in the bottom of the ocean, that's a picture. I took the picture on the right. The picture on the left I didn't take. That's at the bottom of the Marianas Trench, which is like about 10 kilometers below the ocean surface. It's one of the deepest spots the deepest spot in the ocean. And those are like worm-like creatures growing out of rock. And it's very cold. The only light there is the light from the camera taking the picture. And there's gas being emanated of sulfuric acid gas. So stuff that we would normally think is poisonous, very high temperatures. We're finding life, different forms of life, life in places we didn't expect. So what's the key ingredient? We used to think that life required like room temperature. When I say used to, like in the 60s, if you were to find an old biology textbook, you needed room temperature, you need sunlight, you need oxygen, you need energy, and liquid water. And if you didn't have that, you can't have life. Yet we found places where there's life on Earth where all there is liquid water and energy. And energy can be heat, can be electricity, can be anything really. It can be fire going somewhere. So liquid water, that means there's a range of temperatures. We know water is only liquid over a certain range of temperatures. If it gets too cold, it's ice. If it gets too hot, it's gas. So these are keys for where we go to look for life. So let's look around the solar system and see where are places that we can find liquid water and energy. Because from what we see on the Earth, where there's life is pervasive. Where we find liquid water and energy, we see life. When I mean life, I mean like it could be anything from a bacteria to like an elephant. So I'm defining life in a really broad set of terms. So let's look at Mars for a second. This is like a topographic map of Mars made by an instrument. There was a laser altimeter on a satellite that NASA launched in the 80s called Mars Orbiter. And there's black spots on the screen. These are all, let's see, here we go. These are all spots where we've had landings on Mars. This is the Viking lander. Mars Pathfinder landed here. Opportunity landed here. Spirit and Opportunity were two rovers that are still working on Mars. They were launched in 2003. Beagle 2, this was a British mission, landed here, and Viking lander 2 landed here. So you can see, the Mars topography, there's craters. Altitude is, the higher the altitude, the more reddish, brownish the colors are.
Ollie had a question about that.
Yeah.
You said that the only countries that got to outer space was England or
They landed on the moon. On the moon. The moon is much harder to land on. It's a little separate topic. The moon is much harder to land on than on Mars.
Why?
There's no air. You blast away from the Earth. As soon as you escape the Earth's gravitational field, if you head toward the moon's gravity field catches you, and you start accelerating and accelerating and accelerating. The moon's pulling you in. If you go to Mars, you can deploy a parachute. Slow yourself down a lot. You still need rockets to fire, but the atmosphere, the air slows you down. It heats you up, but it slows you down. Mars, unless you carry a big gas tank and a rocket, you're going to slam right into the moon. So the moon is you have to carry your own weight to slow yourself down. So your landing isn't a splat. Your landing, you can actually do something when you land. The other thing is the moon, the temperature swings enormously because there's no air. There's no heat to hold, there's no clouds to hold the heat in. Like clouds, in fact, we have clouds in an atmosphere, makes the temperature of the Earth kind of stable. If we didn't have an atmosphere, besides not breathing, the temperature would vary enormously. So on the moon, in the nighttime, it's about maybe 20, 30 degrees above zero. In the daytime, it's about 500 degrees above zero. So it swings from like minus 250 to plus 250 on the moon. So to build something to land on the moon and survive for more than one lunar day, which is about a month of our time, you've got to build electronics and hardware that can go through really big temperature swings. Here, what's a big temperature swing between day and night? Like 30, 35 degrees. So there you're talking 500, enormous temperature swings. On Mars, much smaller, more like the Earth temperature swings because there is an atmosphere on Mars. So this is a model of the Viking, which was the first lander, next to a very famous astronomer named Carl Sagan. He was sort of the leader of Viking. And Viking landed on Mars in 1972, shortly after humans landed on the moon. And then for a long time, we didn't have any missions to Mars. But here's a photograph, one of the most famous photographs of Viking on the surface of Mars. And the colors are true because you can see the American flag on the lower left. And they put it there not just to give publicity to the U.S. because it was a NASA mission, but to see if the colors were accurate, right? I mean, so you can see the red, white, and blue are accurate. So, if you look at Mars through a telescope, it looks reddish, and you're on the surface of Mars, and it looks reddish, brownish. So that's really what it looks like. The atmosphere looks kind of a little bit orangish. These are true colors. Over time, many, many more satellites have gone to Mars. I forget the count, but it's something like 10 satellites have either gone to Mars, and so it's a popular place to go to. And the reason is because it's so interesting. It's so interesting because it's in that habitable zone, and we see evidence where we think water may have existed. We don't see any. We haven't seen much yet, but you'll see photographs. So you can see there's this gully. I mean, unless there are Martians digging trenches, I mean, if you looked at that picture on Earth, you would think that's a dried up riverbed, right? This was taken from the Viking orbiter mission. Here's a crater. Another picture with a much higher resolution camera. This could look like a mountain range on Earth, taken from space. And this is a picture taken with the high-rise camera. This is the edge of a mountain peak, and you can see. If you look in here, you can see lines where there could be runoff of water. There's another area. I mean, that does look like a dried up river, but I don't know what is. But these pictures were taken in the last couple years. So I'm going to one of the rovers that's still operating on Mars, the Spirit and Opportunity pair that landed in 2003. They were designed to last for 3 months. It's 10 years, and they're still working. What I'm going to show you is a little movie, a little video. It's about 30 seconds long. It was taken. Some of these pictures. It's a fly-around movie. There's not a robot flying around that took these pictures. This is all based on real photos taken both from the rover and from satellites orbiting Mars. And it kind of gives you an idea of what the landscape looks like. It's very cool. So let me turn it on.
Do we need sound?
No, this one doesn't have sound. The next one I did just show sound. This is a very kind of cool fly-around. So some graphic artists took all these photos and created this like 3D fly-around. That is the real rover sitting there on the upper left-hand corner.
And how big is the rover?
The rover is a good question. I'll get to the actual dimensions in a couple charts, but it's like the size of like a lawnmower. Okay. Here's a shot of that same crater. Here's a shot of that same crater. You can see over here, the edge of the rover, looking into the crater. So there's lots of colors. There's winds blowing, sandstorms. There's weather systems on Mars. Now this to me is fascinating. Okay, the Mars Global Surveyor was launched, started orbiting Mars around 1998. It goes back and takes pictures of the same area years later. The upper left-hand corner, here's a picture from August 1999. Same area, September 2000, 6 years later. What's the difference? What's this? What scientists are speculating is that there's a lot of water flowing under the surface of Mars. And occasionally, if there's activity, geologic activity under the surface, some of it might just pop up, like in a spring. And then this is on a slope. It's going to pop up and flow down, and they get reabsorbed into the soil. It's the only explanation for how you can get this, unless there's visitors coming in and digging trenches to mystify us humans back on Earth. I mean, there's only a couple of things that could cause that. So there's about like 10 photos like that have been seen. So that's not a photograph of water, but that's a photograph that would make you think that water might exist on Mars. We've also had landers. We had a lander called Mars Polar Lander that landed on the North Pole of Mars. It's landed on ice. It's water ice. It's not anything else. It's H2O, water ice. So that ice, if you look at photos of Mars during the wintertime, the ice caps are larger. As it gets to Martian summer, the ice caps shrink. What happens when ice melts? It turns into water. Where does the water go? Because maybe it feeds into the soil, maybe there's rivers under the surface of flowing water. There's liquid water and there's sunlight heated life. We haven't found it yet, but remember the key ingredients appear to be there. It's very exciting. And if you look at a picture of, there's a picture of on the left of a region on Mars, of what looks like could be a river delta. And here's a space picture of a region in Iran. It looks almost the same. This is a river delta looking from space. It's all dried up. Here's a picture of an area that looks a whole lot like the same on Mars. So what we think is it's possible in the past, because we see lots of channels and canals, and in fact, when on Mars, people actually thought when we first started building larger telescopes and looking at Mars, people thought there actually were canals on Mars. In the 1800s, telescopes that were larger, we're talking with apertures about a meter or so, and you're able to actually get images on Mars. Lines were seen, and there was some science fiction written in the 1800s and early 1800s about canals on Mars and the Martians. Canals, and not surprising, a lot of Italians were writing science fiction stories about, exploring the canals of Mars. So if you dig into some old sci-fi, you might, find some. So we think in the past, because of all this structure of evidence of water on the surface, Mars may have had a wetter and warmer past. We think. And how could it be warmer? Could have been a denser atmosphere. Mars's atmosphere is very thin, but if it was thicker, that could explain how it could be warmer. And the one on the left is a more modern picture of Mars. The one on the right is just is a speculation from scientists, what we think. So in 1995, there was a piece of rock that was found in Antarctica that came from Mars. Now, how do we know a rock comes from Mars? How would we know that? If you were to try to find a rock that would come from, first, if you were to try to find a rock, where would you look? There's rocks everywhere. The answer is the North or South Pole. Why? Because it's all ice, so if there's rocks, dark rocks will stand out in white ice. You're going to find them. So there are scientists exploring the Arctic regions that are looking for rocks from other planets, believe it or not. That's what they do. So this rock, known as ALH 84001-0, scientists found it, took a chunk of it, put it under a microscope, and this is what they found under a microscope. What does that look like?
A worm.
Could be a fossilized worm, right? And we know. And how do we know this rock came from Mars? When we cracked the rock open, this was done in a laboratory in a vacuum. They analyzed the gas because there were some bubbles of gas, and the bubbles of gas had ratios of different elements that exactly matched the atmosphere on Mars. We know what the atmosphere of Mars is like because we had landers go to Mars with spectra, so we know the ratio of nitrogen, helium, hydrogen, oxygen, whatever. Yeah.
How did rocks from Mars end up in Earth?
So how could a rock from Mars get here?
A meteor.
Very good. An asteroid or meteor comet slams into Mars, and stuff is shattered. We recently found a meteor that we think came from Mercury. If you're interested, go home and Google Mercury rock, and it's very strange greenish blue. And the geologists, the only explanation is coming from Mercury because we actually have a satellite orbiting Mercury now, and so we're actually studying Mercury for the first time. It's sort of close up. We don't have a rover on there, but the rock that we found and what we're observing from Mercury from being orbited around it, it seems like it's a very good fit. So that's how we find rocks. Now, what does it also mean? If an asteroid hits and shatters a rock, and the rock travels across space and lands on Earth, if there was something on the rock, it could come here too, right? So what does that mean? That means if there's life one place, and if it's kind of hardy, it could survive and be planted on another planet. So, it's not out of the realm of possibility that we could all be Martians. I mean, a long time ago, this is, a long time, if life existed on Mars, we don't know this, this is one of the reasons why we want to study Mars. Because if life existed on Mars, and Mars was different a long time ago before there was life on Earth, not that Martians came here and left test tubes, but the origins of life could have started on Mars and been transplanted here, and over billions of years, we could have evolved. We don't know. We don't know, but it's possible. Of course, how does water get on a planet? Does anybody know?
Same as how water is on our planet.
How did water get on our planet?
Condensation.
But where did it come from?
Clouds.
Space clouds.
But how did the water get in the atmosphere? Comets. We believe over billions of years, the Earth started off was just a rock. We believe, scientifically, we believe over billions of years, comets impacted the Earth. Comets are dusty, are ice balls, basically snowballs and ice balls. So over billions of years, comets have hit the Earth, and that's where water came from. When we actually sent some probes to comets to look and see what they're made of, and the building blocks of life are on comets. It's not just water ice. There's amino acids. All the methane, ethane, all these carbon-based molecules, they're on comets. Comets could have brought life. I'm not saying comets are alive with life, but the building blocks of life exist there. So, if you want to find evidence, if there's any life on Mars now, or is maybe in the past, want to look for the water. So where would you find water? So now we get into the rovers. You asked a question before about how big Spirit and Opportunity are. The first rover that NASA sent to Mars was Sojourner. It was landed in July 1997. You can see its mass. It was about 100 kilograms the launch mass, the whole satellite, but the actual rover itself was 11 kilograms. It had about 1 kilogram of payload. By payload, I mean camera, radio transmitters, things like that. The stuff on it that would send back information. And it lasted about a month. And it only, you could go over, it had like a 10 centimeter ground clearance. It really couldn't climb and go very far. It had an interesting way of landing, and I'll show you a picture of that in a second. And then about 7 years later, Spirit and Opportunity, there were two rovers and this is about the height of a human, by the way, from this distance here. Put it in scale. So Spirit and Opportunity landed in 2004. The mass of the rover was significantly more, 179 kilograms, and that's about the size of a lawnmower. And then Curiosity, which just landed last year, is the size of like a small car. And what's also different about Curiosity is it's sort of nuclear powered. The other two, Spirit and Opportunity, are powered by solar cells, by the sun. So they work during the day and they go to sleep at night. And it also means they have very limited amount of power because the solar array really can't take that much power. The batteries are rather small, so it's very modest. Curiosity is very different. It has actually a couple of tubes of plutonium. It gets really hot. Plutonium heats up, and that heat is generated into electricity. So I'll show you a better picture of Curiosity. You'll see in the back, like its fins are the fins of the plutonium rods, and that heat is turned into electricity. So it means is these guys would travel maybe like top speed of about maybe a half a kilometer an hour. So if they want to go a couple hundred meters, it's going to take them like a day to go 100 meters. Curiosity travels about 10 kilometers an hour, and it could travel over its mission. Could be hundreds of kilometers, so it could explore a lot around Mars. Why is that important? Because when you land, you want to land in an area that's flat and safe. But the flat and safe areas are probably also boring, which where you want to land are areas where maybe you're at the edge of a riverbed or there's a crater and a drop off and maybe evidence of water. But with these guys, if you land, you have to land really close to the edge of the crater, and if you miss, there goes $1 billion out the drain. It doesn't survive. This mission, because of its the design as far as it having better range, it's going to be much more productive scientifically. It's going to be able to explore many more areas around Mars. So this is an example of the different sizes of the wheels. So the first lander, the way it landed was rather clever. It used a parachute to slow down, and then at about 100 kilometers high, these airbags inflated. The rover's inside, so it basically fell and bounced and bounced and bounced and bounced. It took about half an hour for the bouncing to stop, and it was designed that once it stopped, all the air would be let out, and the rover could flip itself over, and it started working.
Was there a video of that on YouTube?
I think there are some
saw
videos
that,
of that. Yeah. It's an animation, or maybe even a drop test on the Earth. They probably had videos of it on YouTube. A very clever way, because that way this didn't need any rocket engines. So you could land. You couldn't do this on the moon because you'd be coming in so fast. You'd be bouncing for probably almost like weeks until you settle down. It's not really a practical solution.
How did the airbags detach once it landed on them?
They didn't. They just flopped. So it actually they let all the air out, and it just sort of like a flat parachute, and it just turned on. You turned on the wheels, and it just drove off and drove over the.
Wow.
It's a very thick cloth. It's like thick parachute material. So here's a panorama taken from the Sojourner. Again, this is a rover about this size, tiny little rover. I mentioned Spirit and Opportunity. You can't read this, but this was the timeline starting up in 2003.
Are they two different rovers?
Yeah, one's called Spirit, one's called Opportunity. They've landed on different sides of Mars. The guys that proposed the project, see, if you design and build something, to build a second copy is only a small extra cost, because it's real hard to design and build something from scratch, and to build a copy is pretty cheap because you've already done all the work to build one. Just buy 2 of all the parts and just build 2 of them. So they convinced people at the NASA Jet Propulsion Lab in California came to NASA headquarters and said, look, you've given us $600 million to build one. For $750, we can give you 2. And there was extra money in the budget, so they put in $150 million more, and they got 2. But these are still going. This chart I put this together last year, 2012. So these are major events in terms of significant discoveries. This was designed to last 3 months, and it's lasted 10 years. It's great. I mean, you build something and it lasts much longer. It's wonderful, especially considering how expensive and hard it is to get to Mars. So here's Curiosity. Here's the one I was just talking, the larger one I was talking about. Here are the radiothermal generators in the back. So these are rods of plutonium, and in these black areas, this is where the heat is converted into electricity. This is a camera here. It can swivel around. It's a high definition camera. It has rock crushers. It has rock pulverizers. It has a little chemistry lab inside. There's an arm that can grab a sample, bring it in, pour different kinds of acids on it, and see what's inside. It's like a chemistry lab. So it has a laser on it, so and it has a drill, so it can drill into rocks to get a rock to break apart. There's a laser to heat up or something if you want to burn. If you think there's something that you want to burn something off. So and you can do this because you have power because of the radiothermal generators. In the back.
Wait, can I ask another question? Is there someone from NASA controlling this the whole time it's there, or it's done automatically?
Very good question. Yes, all these missions are controlled from the ground, but good question. How long does it take for a signal to get from the Earth to Mars?
16 hours.
A radio signal?
I don't know.
It's about 15 minutes.
Whoa.
So what that tells you is, so you're getting a picture that was 15 minutes ago, right? And you're saying turn left.
It's the week 15 minutes.
But see, it's not going to sit there and wait. So